Hi, today we are going to cover finite state machines. Last week we have seen relations and directed graphs. So relation is about two things, basically two sets, and we can use this relation on a single set, and we already know about these kind of relations about inequality, equal, or subset, or uh, congruence, and this kind of specific relation. And there are four different properties, which are reflexive, which is about null itself. So there is a relation between A and A itself. So this is reflexive. And another one is symmetric and anti-symmetric. They are opposite. So when you have two elements, they have this relation, and the other direction also available. That's symmetric. Or you have two elements, there's nothing. That's also symmetric. Anti-symmetric is not available, that kind of thing. So last property is transitive. If you have this relation, maybe there is another relation with connection is available, that is transitive. And we have seen this combining two relations. So when you have two relations, you can use this composition to combine those two. Here we have sister circle parent, which is sister or parent. That means y is an aunt of a x, and we have another one, parent of sister, y is the parent of x. We can describe a relation using this combination. So if we have uncle, we can say this is brother circle parent, brother of parent. And we have cousin here, that would be child of sibling or parent. That means child circle, sibling circle, parent. And there is power of relation. When you have square, it is about R circle R. And when you have R zeros, that is about equality. And R1s, that is definitely same to R. So R to the multiples, it is about the combination of several R again. And we can describe this relation using directed graph. There is a path and several kind of paths. Simple path is about the single way, and cycle has a repetition inside of this path. Simple cycle has one repetition on starting and end point, and we have seen we can use this graph to combine two relation. Here we have S orange, R purple. So when you combine them together, we can make this graph again. So we can simply write down this kind of graph and find the combination of paths, and we can check this kind of connectivity. So here we have a graph that has several relations. So when you want to find this connection, the connectivity inside of that, so you can try to apply this transitive-reflexive closure. So which need to add minimum possible number of edges to make relation transitive and reflexive. This is about the connectivity relation R star. So it needs to be reflexive. We have to add all this kind of relation, this self-proof for the reflexive property, and we also need to add this relation to make sure the transitive. So here, this node can be moved to be here and there. So we need to connect these things to make this connection, to make sure these connections. And we also have seen about the applications. We can use a relation on database. So here is student table and course table. So maybe we can combine them together using this relation. In this case, we can connect them together with ID number. And we have seen several database operation. First one is projection to find a specific column, and there is selection to apply the condition. In this case, we can try this GPA is greater than 3.9 on student table, and then we can also combine those two, projection and selection. Then we will get this result. Or we can join those two tables together to make this full table to see all the information in a single table.